What I do really quickly, I hack Lisp professionally, mostly CL, and in my free time I hack mostly eLisp for Emacs, of course. So I'm concerned with the tooling for CL and also for eLisp, but I'm not a common Lisp expert. Nevertheless, one of the things I noticed is that common Lisp, although it has great debugging facilities, was missing a portable stepper. What is a stepper? A stepper is oops. Stepper is something like this, of course, that you have in Chrome, for example, or GDB, a great example of a stepper.
Microphone closer to the mouth.
Right. Sorry. So in 2020, I presented a paper to ELS. I didn't get to present it. It was accepted, but I didn't get to present it basically because the pandemic appeared and I was too lazy to record a talk. So today I want to demo this stepper and not go into the details of how it works, but at least I would like you to I'd like to show to you how it works in terms of an interface. Let's see if I can do that in the little time I have left. Where can I put the microphone? So might as well switch over to this terminal and try to look at it.
Would you mind removing the mask?
Okay, no problem. So let's say I'm in local project. This is a quick Lisp file, and
I'm not sure that's useful, is it?
no, it's not particularly.
The
It's
mic.
sorry.
I mean the mic. I'm not sure we can hear you.
Okay.
This is complicated.
Right. So I'm going to show a feature of the IDE, and I'm using this very similar to Slime, but it's called Sly. And this feature is called sticker. So you see I highlighted this atom and I highlighted this whole form, and then I'm going to compile the definition, and they're going to turn blue, which means that they are armed stickers. So if I execute this code, the return value of those two forms is going to be recorded. But if, for example, I put a sticker here and I try to compile the whole form, this doesn't make any sense because that atom isn't evaluated. So if I compile this, you say, oh, stickers fail to stick. So normally, this is already a good way to debug code because I can now run the code here, and then I can retroactively inspect what each sticker returned. But I wasn't satisfied with this. So the idea, because I was mostly, when I was doing this, I forgot, oh, I want to instrument that other form and that other form. So I wanted something automatic to instrument all forms that are evaluated. And this is what I did with the stepper project, which is it reads the code, records the source information, and then macro expands the code up to the 20-something most basic special forms, and that communicates this information back to Emacs, which then places the sticker, and then I can compile this and they all turn blue. It's not instrumenting the things like index. It's not perfect. You might have noticed there are some limitations here with some macros, and regarding atoms, I had a talk with a chat with Michael Raskin, whose library I'm using, and so we can go over those. And okay, and so when I have this, I run this, and then I can forget the old ones. Yes, I want to forget the old ones. And so this is how it works, and you can step through it. This is stepping retroactively. It's not actively using break, but you can configure it to use break if you do this. Let's see. Oh, sorry. Yeah. Okay, so there's a little and I can continue here every time I want to see. It shows me the return value. So basically, despite the limitations, I think this is very useful. Every time it misses one of these atoms, you can always go and put it there yourself, and you recompile. If you're not interested in some return value, you can also remove this. The interface is not as nice as most steppers, but it's still pretty useful in my opinion. It works in practice for most of the situations I could give it. Thank you very much.
Thank you.